Center sends out hormones?
Yes.
Okay.
The reason this is important is because most of the negative feedback loops you'll need to know this semester, you'll need to know a hormone involved in it. I know the example, one of the examples he mentioned was blood sugar levels. The hormones there, like insulin. But you guys are going to learn about that later, so I don't know if he expects you to know that one.
How about temperature?
Probably just body temperature because that's a very basic one. Okay, so we have our line, homeostasis. This is where our body wants to be. So coming out to the library today, took a step out my door, all of a sudden my body temperature went down. And the sensor's constantly telling my control center the levels, so the sensor's constantly, receiving that information and then giving it to the control center. So in this case, in body temperature, the sensor and control center are both the brain. I don't think he expects you to know which part of the brain. You do, it's hypothalamus, but I don't think he wants you to know that. So the sensor and the control center is the brain. And so then that information sends to that part of the brain that's the control center and it goes, ooh, Ben's cold. We need to fix this. I don't like this. We want to be back up here. So control center then sends a signal to my muscles, which are the effector, to start contracting or shivering. So I'm shivering and those contractions are actually warming me up. Also, the blood is brought away from the surface of the skin, so I'm not losing heat through the blood vessels and stuff. So my body temperature eventually warms up. Now today I have a class on the RICS, and the RICS is always a huge long hike and I hate it. So let's say I get to the RICS. By the time I get there, I am hot. I just worked really hard hiking up that hill. So my sensor is sensing that, just getting the information, sends it to the control center. Control center goes, oh wow, we're hot now. We're really hot. But we need cooler stuff down. So the control center sends a signal to the sweat glands. And the sweat glands are the effector, and they release sweat. And also the blood vessels, go to the surface of the skin to release heat, and that brings me down here.
So the effector is just like, the effector is a different thing. It's not the same thing all the time.
No.
Okay.
All these are different things depending on what you're talking about. We're talking about body temperature. There are certain things for body temperature. If I was to talk about blood sugar levels, they'd be all three would be totally different things.
Okay.
It's just the same process.
It's the same process, exactly.
But in this case, with the temperature, there's no hormones involved.
You're right. Okay. Correct. Yep. It's just a signal sent from the brain, like an action potential or a signal in the nervous system. And so our body all day long does this. There's no time where we're ever just flatlined. Like, we're just staying really close. Our body's just trying as hard as it can to stay as close as it can to that line. It'd be in a perfect world we'd be right there at homeostasis all the time, but there's never, we're never just straight. So, that being said, I want to explain positive feedback loop really fast. The difference between them. So is everyone okay with this and understand this little diagram? Okay. So there's only one positive feedback loop I know in the human body, and that's childbirth. Well,
That's it?
that's the only one I know of, and the only one
He
I've
talked
ever
about
taught.
he talked about amputation. He said that could also maybe potentially be one. Didn't he say that in class? Is that just me?
I don't know.
Maybe.
I thought it
Brother
was
Ray knows
amputation.
more than I do, but the only one I know of is childbirth.
But yeah, that's what he was.
So here's our original state. We're going to call this original state P for pregnant. We're pregnant. That's our original state. The baby gets big enough where the head actually presses on the cervix, which actually causes a contraction. So we have one more contraction. Now, contractions actually stimulate the release of a hormone called oxytocin, which causes more contractions, which causes more release of that hormone, which causes more contractions, which causes more release. And all of a sudden we're up here at baby. We have a baby. The difference is, negative feedback loop, we're trying to stay at our original state. Positive feedback loop, we're getting way far away. We're not, at the end of childbirth, you're not pregnant again. It's not, you're not going back to your original state. You're changing states. You know, something keeps leading, it's like a ball rolling down the hill, like a little snowball. If you roll it down the hill, it gets bigger and bigger. It's that sort of concept. You start something and it keeps going, and then you have an end result, which is different than the beginning result. Most things in the body, they want to stay at the same level. So negative feedback loops is how majority of the body works. But here's an example of positive feedback loop.
So your and when you have a baby, all your hormones level change.
Your hormone levels.
Things happen.
Your hormone levels would change and stuff. We'll talk about that when we talk about reproductive system. But your hormone levels will go back to normal and stuff like that. But the actual condition or state you're in, the snowball effect. Yeah, that's.
And what was the hormone again?
The hormone's oxytocin. You won't really need to know that until we talk about chapter 13, the endocrine system. But. So, any questions about negative feedback loop?
No.
So if I were to say on a test, name all 3 parts of the negative feedback loop and explain to me how it works, do you guys feel confident you'd be able to do that?
Wait, what?
Sensor, effector, and
Control center.
Sensor, control center, effector.
So is it sensor first?
Yeah.
Okay.
Sensor collects the data.
Mm-hmm.
Control center interprets the data.
Perfect.
And then sends a message to the effector to make a correction.
Yep, and the effector changes something. Perfect. And that's how it works. So those are the 3 parts, and that's how they work with each other.